We're on. Okay. So now we're going to talk about the use of the word normal in statistics. This is a very important word, and it has a very specific meaning in the mathematics world, okay? So here we go. What you see behind me is a dot plot for Russell Wilson's 2017 NFL season touchdown passes. So let's review. You can see he has 1 game with 0 passes, 3 games with 1 touchdown pass, 0 touchdown passes, 7 games with 2 touchdown passes, 3 games with 3 touchdown passes, and 2 games with 4 touchdown passes. What's nice and interesting about this data is that you can see 7 games at 2 with a pretty nice distribution, almost perfectly symmetric, right? That's going to be the key other word, symmetric. Now, that is a mathematical word, right? Well, in the land of statistics and probability, we use symmetric and normal are essentially the same thing. And by symmetric, we mean right around the center, right? And if you think about it in life, a lot of things, a lot of data is symmetric. And the phrase I'm going to use from now on is normally distributed. Think about it. SAT scores. There's a whole bunch in the middle, a few on the low end and a few on the high end, right? Normally distributed. How about height of human beings? Whole lot of people right around 5'6", some taller, some smaller. Normally distributed. Shoe size, normally distributed. My brother wears a size 13. He can never find any shoes. Why? Because everybody's around a size 8.5 to 10.5, right? Ever try to find shoes that are way big or way small? You can never get them, right? Because they're way out here. Very few people have them. What else is normally distributed? Grades, right? Big cluster at Westminster School around the high 80s, some lower, some higher, right? Normally distributed. So that's what we're looking for with a normal distribution. And if we were to kind of connect this dot here, oh, isn't that nice? Does that look kind of familiar to you? Yeah, maybe you've heard of it before in life. It's called the bell curve, right? But here's our normal curve. And when we say symmetric, we mean it's normally distributed around the mean. Now, why the mean and not the median, you ask? Well, if data is normally distributed, the mean and the median are going to be about the same. And if the data is normally distributed, the standard deviations will be similarly placed, right? So let's say I've got an SAT. SAT has a mean of 1,000 with a standard deviation of 100. Each standard deviation goes down that much. But let's say also that grade point average is normally distributed with, say, a mean of 88 with a standard deviation of 2. So that'd be 90, 92, 86, 84, right? How about shoe sizes? Average shoe size might be an 8 with a standard deviation of 0.5. 8.5, 9. 7.5, 7. And here's the big thing about standard normal distribution. Here is the big thing about normally distributed data. The same percentage is between the mean and the first standard deviation. And it doesn't matter whether you're talking about shoe size or SAT scores. That's a fixed value. We say this is 34% of the data. And I'll show you where that number comes from in our next video. So what does that mean? That means if you're going to say, well, this is normally distributed, whatever, then I know right away 34% of the data for the SAT is between a 1,000 and 1,100. That's true. I mean, it varies slightly, but if you want a good estimate, I will tell you right now, 34% of the kids who take the SAT score between 1,000 and 1,100. 34% of the kids at Westminster score between 88 and 90. 34% of the people on the planet have a shoe size between 8 and 8.5 US sizes. That's all true. Why? Because we assume the data is normally distributed. If you're going to use that word, that's why this is such an important word. Normally distributed. Well, this allows us to calculate a lot of things. And this is the normal curve. And that's how it works. So below, because it's symmetric, that's also 34%. Wow, that's pretty cool. 68% of the data is between plus or minus 1 standard deviation. That means 68% of the kids score between 900 and 1,100 on the SAT. Normal distribution. That's what it's all about. Now we're going to talk about how to calculate all this, but I'm going to show you one formula today that helps us get there. How do I know 1,100 is 1 standard deviation above the mean? Because I know the mean and I know the standard deviation, right? I take my data point, which we'll call x sub I, subtract the mean, divide by the standard deviation. And that gives us what we call, drum roll please, the z-score. So -1, -2, 1, 2, and then 0 right at the mean. These are what are called z-scores. All right, those are what are called z-scores. So in other words, the next time you get your SAT, you don't want to know what score you got, 1250 or 750. You want to know your z-score. I got a 3.5 on the SAT. That means I scored 3.5 standard deviations above the mean. Well, I got a negative 1.75. That means you're negative 1.75 standard deviations below the mean. That's what the normal curve measures. Now, if you watch some of the other videos on our course page, you'll see a more explanation of how this works. But this is how we deal with normally distributed data. Until next time, carry on.